Welcome back to structural dynamics class. In this module we will study transmissibility. So what is transmissibility? So transmissibility is when a force is applied onto a body, how much force is getting transmitted. So that is transmissibility. So as an example, if we look at, say, a vehicle is passing on the road, vehicle is on the road. So vehicle has a certain weight and then it is transferring the force to the supporting road. So how much force is getting transferred to that, that is called transmissibility. So we will discuss that. In a static condition all load will be transferred, but in dynamic condition it depends on the speed of the vehicle, it depends on the natural frequency of the vehicle, and then a damping present in the system. So all these three things. So how we work out the force which is getting transmitted, that we will discuss in this class. So transmissibility is, it is a ratio of amplitudes of the applied force and the transmitted force. So if you look at this figure, this is a idealized mass, spring and damper system. So mass is representing the entire mass of the vehicle, and then stiffness and damping together, they are representing the suspension of the vehicle. So usually we have shock absorbers, tires and all those things, that is the suspension of the system. And you can see here this PT is the force applied. So this has two components in it. One is the amplitude part of it, that is P0, which is amplitude, and then the second one is the sinusoidal part of it. So this omega is a dynamic part of it. So this is dynamic part and this is static part, and because of which this mass is vibrating. So this U, which is measured at the center of mass, is the displacement of the system. And when it comes to, when we look at the bottom here, like the tire is in contact with the road. So in a way this P sin omega t, this sin omega t is coming because of the movement of the vehicle on the road. If it is flat, then this omega will become very less value. If it is, say, bumpy kind of road, this value increases, and that also depends on the speed of the vehicle. So now vehicle is moving in the towards the right side, and then if it is very high speed, then omega will increase, low speed omega will decrease, like that. Then Ft is the force which is getting transmitted to the base, okay, and then Ug is the ground displacement. So the displacement which is imparted because of the road. Now if we calculate this Ft, so Ft has two components in it. One is stiffness multiplied by the displacement and damping multiplied by velocity. Two terms, stiffness multiplied by displacement and damping multiplied by velocity. Now let us find out the solution of this like equation of motion. If this is the proposed solution or the solution, that is ut is equal to u0, which is amplitude, sin omega t minus phi. So phi is the phase angle. Ut is equal to u0 is nothing but u0 is equal to ust into rd, or rd we know is the ratio of dynamic displacement to static displacement amplitudes. This is an equation. Now if we substitute this in the above equation of Ft, so what we will get, let us see that. So k into u ut and then c into u dot. So if we differentiate that u once, so what we will get is from this one. So if we differentiate this one, so what we will get is omega comes out, okay, and then that becomes cos, as you can see, okay. So ust into rd omega cos omega t minus phi. So then upon further simplification, ust into rd can be taken out, k sin omega t minus phi, c omega cos omega t minus phi. So what is important to us is the amplitude. So amplitude of this sin and cos is, like if we have A sin theta plus B cos theta, amplitude of vibration is square root of A square plus B square. So that is what is worked out. So this is a coefficient and C omega is a coefficient. So UST multiply by RD under root K square plus C omega square. And here you look at it, this is a amplitude, this is a variation with time with time function, and this is only amplitude. So we are taking out amplitude from it, and then UST is nothing but P naught by K, RD value remains, K if we take out it is 1 minus C omega by K whole square. So upon further simplification of expanding of the values, okay, of C, so 2m zeta omega n is a C value. So if we expand it, it looks like this, and upon further simplification we get, so if we substitute RD also in this one and then take the ratio, okay, this P Ft divided by P0. So Ft is the force transmitted and P0 is the amplitude of the applied force. So amplitude of transmitted force by amplitude of applied force is equal to like RD into under root 1 minus 2 zeta square whole square. If we put RD value in this one, so what we will get is this. So amplitude of applied force, transmitted force by amplitude of applied force is equal to this whole big equation, that is actually equal to amplitudes of this one, u double dot 0 by u double dot g0. This is applied force and that is a transmitted force. Now let us solve one problem using this principle, okay, to understand this phenomenon a little bit more. So a weight of 150 kg is acted upon by vehicle of force F 300 sin 6t. So this 6 is a forcing frequency and 300 is the amplitude of that force, and damping assumed in the system is 10%, and if stiffness of surface on which vehicle is resting is 50 kilonewton per meter, find the amplitude of force transmitted. So let us first find out natural frequency, which is under root K by M. So K is given as 50,000 and mass is given as 150 kg. So with that we will get 18.26 radians per second. So that is natural frequency. Then frequency ratio, forcing frequency is 60. Oh, so this is 60, not 6, this is 60 sin 60t. So forcing frequency is 60 divided by 18.27, so that is 3.26 is R. So frequency ratio R. So if we find out static deflection, that is P naught by K. So force amplitude is 300 and K is 50. So if we take the ratio, we get 6. Then steady state amplitude is U is equal to U0 sin omega t minus phi. So displacement response factor, so with this one U by UST is equal to RD, that is 1 by all these values. So UST we know, UST value we have put there, and Ft by P0 is 1 plus 2 zeta R, all this value. If you substitute appropriate values in that, so we get 0.124 as a ratio. So if we want acceleration t, which is transmitted value, is Ft into 0.124 is equal to 0.124 into 300 given, so 37.11 kilonewton. So when the force applied is 300 kilonewton, the 37.11 kilonewton is the force transmitted. So in this class we have studied how the force is transmitted from the moving vehicle onto the road. Like it depends on like 3 factors. One is weight of the vehicle, and second one is speed of the vehicle, which is deciding the frequency of application of force, and then third one is damping, so with which the load is getting transmitted.